So good afternoon all. So this is our second session uh, for this course, Advanced Machining Processes. Okay, so I can see there are a few questions in that Excel sheet. So I'm going to answer all these questions and show that questions. Okay, so how electrochemical grinding grinds the surface. Okay, so for that, I'm just PPT. Okay, so suppose this is the grinding wheel here and this is the workpiece here. So in this case, electrochemical grinding process, in between this workpiece, okay, so this is the grinding wheel which is rotating. Okay, so here, these are the abrasive particles are there. So this is the abrasive, this kind of abrasive particles are there. And so this machining occurs actually because of this electrochemical dissolution, just like in normal ECM process. In between this negative terminal of this circular grinding wheel, and this is the positive terminal of, or I can say this one is actually anode, and this wheel, the grinding wheel, it is actually cathode. So this grinding wheel in this case, it can be made of graphite material, which is very soft material, and it is mixed with abrasive particles here. So there will be electrochemical dissolution in between this cathode and anode. And what happens actually, these abrasive particles, it removes the oxide layer, whatever this metallic oxide, whatever is actually metallic hydroxide, which is actually removed as in salt in electrochemical machining process, that is removed by these abrasive particles. Also, there are some kind of passivation layer which is generated. Passivation layer is generated on the workpiece surface. So this passivation layer is nothing but actually this oxide layer. Unless this passivation layer is removed uh, by some kind of means, okay, so it is very difficult to get a continuous material removal rate by this ECM process. So this passivation layer is removed by the these abrasive particles. Okay, so what happens actually, it rotates. Because of rotation, whatever these debris particles are there, so these are the debris particles. So because of rotation, whatever these debris particles are there, it is removed because of this rotation. And so there is in normal ECM process, there is chances that actually there is inter-electrode gap, which is this inter-electrode gap, which is blocked by these debris particles, metallic debris particles. So in ECM electrochemical grinding process, as the wheel is rotating with a high RPM, so these debris particles are removed, and whatever this passivation layer which is deposited on the anode surface, that is also removed. So phase metal actually comes and so it helps in actually ionic dissolution. Okay, so that's why this grinding in electrochemical grinding ECG process works. About the nature, pattern, and marking scheme criteria for online examination held in December. So this pattern will be MCQ type questions. So we shall take a few questions as actually as a recall type questions. Okay, so whatever given in the PPT and I have discussed during this in the lectures. So you can recall, if you see, if you go through this actually this PPT, you can remember. Okay, so some physical phenomena that I have given. So that is recall type. And after that, few assignment questions I have given. So it is totally, it is almost copied from the whatever assignment is given. Okay, so from this assignment, I think total 8 assignments have been given. Okay, so from assignment, around 15 questions are there. And then some questions which is actually open type, which is a little bit actually difficult. So that kind of questions I have given. To differentiate between different classes of students. Okay. Now, third question is which process EDM, ECM, ultrasonic machining, and laser beam machining has highest material rate? Okay, so out of these four machining process, EDM is actually thermoelectric process. Uh, so ECM, you know this actually, it is a electrochemical machining process, and ultrasonic machining, it is a mechanical type machining process, and laser machining, it is also thermoelectric process. So out of these four, this laser beam machining EDM, these both of these two EDM, electrodischarge machining and laser beam machining, are thermoelectric process. So an ECM process, we are using actually electrical energy for chemical changes in the electrolyte. Okay, so it because of this ionic dissolution, machining occurs in electrical machining process. Now, in ultrasonic machining process, it is a mechanical type machining process, advanced machining process. So, in this case, actually, material removal mainly because of these abrasive particles, which is hit by the horn, which is means vibrating uh, at a frequency which is more than audible range of human ear. So it is 19 kilohertz. So means it oscillates at a ultrasonic frequency, and because of this horn which hits the on a tool which hits the actually these abrasive particles which is in the micron size, and that abrasive particle again hit some of the other abrasive particles, and these abrasive particles are hit to the workpiece surface, and on brittle workpiece there is a brittle fracture. So very small tiny chips, micron sub-micron range tiny chips are generated in case of ultrasonic machining process. So in ultrasonic machining process, whatever this machining is actually very slow. Machining rate, material rate, if you see in ultrasonic machining process, it is very low. And after that ECM process, here actually atomic dissolution is there in between this cathode and anode. So because of this material removal occurs atom by atom from the workpiece surface, then ECM process also little bit slow process. Then after that in EDM process, sparks are generated in between these asperities where their distance is less. Because of this micron size spark or crater is formed from the anode or workpiece surface, so machining occurs. So there are thousands of crater which generates because of the thousands of sparks which forms during machining process. Okay, so that's why this in EDM process, because of the small craters are generated, here also machining rate is little bit slow as compared to laser beam machining process. But in case of this laser beam machining, this heating on the workpiece surface, because of this actually photons, these photons actually hit on the workpiece surface, and that is a this laser beam diameter maybe 1 or 2 millimeter diameter. In some cases, CO2 laser 3 millimeter, 4 millimeter diameters of spot diameter is there. So here actually intense, huge amount of intense energy, it falls on that actually small 2 to 3 millimeter diameter on that workpiece surface. So here, whatever this volume material rate, so volume, whatever this metal melts or evaporates in this case, it is actually a little bit higher. So here, so because of this melting and evaporation of this molten material, and in a bigger zone, like 3 millimeter, 2 millimeter in that in that diameter, it happens that entire area actually melts and vaporizes. So that's why actually, if you consider this four EDM, the same ultrasonic machining and laser beam machining, this laser beam machining has higher material removal rate than EDM, ECM, and ultrasonic machining. So among these four, ultrasonic machining has less material removal rate, lowest material removal rate, then ECM process, then EDM process, and highest material removal rate in laser beam machining process. Now, next question is how advanced machining helps in development. Development means actually what development, it is not clear here. Still, actually, I can tell actually its influence because if you see most of the components nowadays are very complex geometry. So, so earlier days, big machines are actually utilized. Nowadays, people are reducing the size of these individual machines. So, also we are actually processing very hard, difficult process materials nowadays. Okay, so earlier days actually this material, whatever it is material, was not uh, that much harder. Okay, so but nowadays actually high strength, temperature resistant, these kind of materials are used in aerospace industries, space industries. Okay, so like pneumonics, titanium, uh, so these kind of materials which are very high strength temperature resistant material, so having a very hardness, high hardness. Okay, so in for machining of this kind of material, we need actually advanced machining process. Also, we need actually this geometry, which is very complex in nature. So this various complex contour has to be made on a single workpiece, which is very difficult in normal or conventional machining processes. Okay. So also the surface finish requirement is very high nowadays. In some cases, actually, like if you consider the lenses, which is used in actually missiles, so in that case, this surface damage requirement is in the angstrom level. So that's why so these advanced machining processes are actually too much important nowadays. And also we need machining where it is not inaccessible. Okay, so in accessible areas, you can do the machining by like laser beam machining, where your these inaccessible areas where you can put your this laser beam, you can and then that laser beam can do the machining. Also, if there is a transparent surface is there in between, through the transparent surface, you can do the machining by laser. Okay, so inaccessible areas also you can do the machining, which is not possible in normal conventional machining process. So for actually industry nowadays, these advanced machining processes, which are nowadays has become actually normal. So it has become earlier days it is called actually advanced machining process, but nowadays it has become like a conventional machining kind of thing. So that's why for industry development of industry, actually it is very much required. So other questions, I don't think actually it is clear. So I request all the participants, you can ask me question if there are any doubts, so I can clear them. Okay, so mechanics of chemical machining process. Okay, so this chemical machining earlier days it is used for making ornaments. So that time actually for making different kinds of ornaments they used to do. But nowadays actually this chemical machining like photochemical machining it is very much uh, uh, means means very much it is used in industry, this photochemical machining. In this chemical machining process, what happens actually, suppose you want to make a component there. In chemical machining process, suppose you want to make a component. Okay, so what happens actually on a substrate surface where you need this etching. So in chemical machining process, actually it is like a chemical etching of different acids or base. So by chemical etching process, actually this machining occurs. Okay. So what happens on a substrate surface, wherever you don't need uh, wherever you don't need actually any machining, there one etchant means one layer which is actually chemically resistant layer which is placed over there. So that layer actually there are different ways are there. There is a cut film method or there is a screen printing method. Okay, so this chemically agent, it like a spray coating kind of thing. Okay, so wherever you don't need, so that surface actually just you cover with this kind of chemical resistant material, and other surface where you are not putting that thing. So in that case, in that area, you just start doing chemical reaction by this agent. So this agent, it may be nitric acid. For hydrogen, for titanium machining, it is HF. Then it may be ferric chloride. Okay, so there are different kinds of agents which are used. In among all these actually method, photochemical machining process, which is more accurate among all these other chemical machining process. So in photochemical machining process, what happens on this substrate surface, where means whatever this complex, generally actually some complex contour which is generated by using this photochemical machining process. So earlier days, what happens actually, people used to do, artists used to do a bigger size drawing, and then they make a smaller size on a photographic film. Okay, so nowadays actually you can use the CAD model and you can develop using this laser. You can develop on a for photography film. Okay, and then you just on the substrate surface you just keep your this film, and before that actually you just put this some chemicals actually which reacts with the ultraviolet ray. Okay, so using UV ray you just cure that chemical, and then that portion where machining actually required, that portion it will be removed there. Then wherever it is not required, that portion it is cured and baked, and then you can do the chemical etching process, that normal chemical etching process. For that you just dip that workpiece into the etchant bath. So to maintain the temperature, you can fix the you can maintain the temperature inside the chemical bath, because with the increase in the temperature, so there is a more chemical reaction, higher rate of chemical reaction will be there. So in that case, whatever this H factor will be different. Okay, so there may be some inaccuracy whatever is generated, because there is a side cutting in case of actually chemical machining process. So so to avoid that, actually there are some other methods actually which is used. Are the modulars over? So I don't understand what you tell Stanley. Are the modulars means? Sorry, I don't understand the question. Uh, any other question you can ask? Okay, modules. Which modules? So all the modules are there. So there is no any other modules. So it is a weighted course. So whatever syllabus is there, it is already completed. So you can see, you can go through the syllabus. Okay, so no other module will be added there. So is there any question? Any more question? Okay, I think there is no more question. So we are winding up. So if you have any more question, you can contact me. Okay, so in MOOCs forum. Okay, so you can contact me and I shall try to answer most of the questions there. Okay, so right now we are winding up as there is no more questions.